Now in this lesson, we're going to learn how to solve a particular type of chemical calculation questions in which both the amount of both reactants are given in the question. Now let's take a look at this real life example. A pastry chef has 3 puddings and 6 raspberries. Now how many bowls of dessert can he make? Alright, I'll give you 5 seconds. From the picture, I'm sure you can tell that the chef will be able to make 3 bowls of dessert. Okay, how do we know? Because from the picture, each pudding must be matched with 2 raspberries. Alright, so 3 puddings and 6 raspberries, we can make 3 bowls of dessert. Okay, we have just nice the amount of raspberries to pair with your pudding. Okay, when we have just nice the amount, we say that they are in stoichiometric ratio. Okay, now in this second scenario, the pastry chef now has 3 puddings and 10 raspberries. How many bowls of dessert can he make? Again, you should be able to tell me that I can only make 3 bowls of dessert. Okay, but then I will tell you that I have more raspberries now. Alright, I have more raspberries. Why is it that I don't get more bowls of dessert? Right, reason being, I still have only 3 puddings. Okay, so the puddings is limiting the number of bowls of dessert that I can make. So now your pudding is your limiting reagent. Okay, and we have too much of raspberries. Okay, we have too much of raspberries because each pudding only requires 2. So 3 puddings will require 6. We have 4 raspberries remaining. Okay, so raspberries is your excess reagent. We have too much of it. Now one more example. So in this example, the chef has 5 puddings and 6 raspberries. So how many bowls of dessert can he make? Again, the answer remains as 3. Okay, why is it 3 even though we have more puddings now? It's because we only have 6 raspberries. Okay, so we do not have enough raspberries to make more bowls of dessert. So now your raspberries is your limiting reagent. Okay, whereas your puddings is in excess. Okay, we have too much of puddings, too little of raspberries. Now, so how do we apply it to chemical calculations? In chemical calculations, when the reactants are added according to mole ratio, that means in just nice amount, we say that it is added in stoichiometric ratio. Okay, when we have too much of one reactant, that reactant is in excess. When there's too little of one reactant, we say that the reactant is limiting. Now let's try to apply the concepts of limiting and excess to this particular example. But before I go on to show you how to solve this equation, I want to point out something. When you look at the question, they tell you that 2.3 grams of sodium was reacted with 0.5 moles of hydrochloric acid. Now in this reaction, sodium is reacting with hydrochloric acid, and the question states the amount of both reactants. Okay, so whenever you see a question where the amount of both reactants are given, it is a signal to you that is a limiting excess type of question. Okay, I repeat again. If a question gives you the amount of both reactants, it is a signal for you that it is a limiting and excess type question. So we need to find out which reagent is limiting and which reagent is in excess. Okay, how do we find out? There's again an approach for that. Now the approach is as follows. So first we need to calculate number of moles of both reactants. Okay, so whatever quantity that's given, we convert it into moles. Then we pick any one reactant. Okay, it doesn't matter which reactant you pick, you will still arrive at the same conclusion. So pick any one reactant, right? Use mole ratio to find the number of moles of the other reactant needed. Alright, so if we were to call the reactant that you pick as reactant 1, using the number of moles of reactant 1 and the mole ratio, we find the number of moles of reactant 2 that's needed to react with reactant 1. If the number of moles of 2 needed is more than the number of moles of 2 present, then it means that 2 is limiting. Okay, the alternate scenario is that the number of moles of 2 needed is less than the amount present, then 2 is in excess. I know again it sounds very abstract at this point in time. Let's apply this to the question again. So step number 1, we're supposed to find number of moles of both reactants. So number of moles of sodium is actually equals to mass divided by molar mass, which is 0.1 mole. Okay, and number of moles of HCl is already given in the question, so there's no need to do any calculations. So this is step number 1, find number of moles of both reactants. Now step number 2, we can pick any reactant that we want, right? So I'm going to pick sodium first. So later I will show you that we'll arrive at the same conclusion if we were to pick hydrochloric acid as well. Okay, so picking sodium, we know that number of moles of sodium is 0.1 moles. Okay, now we need to find 0.1 moles of sodium will react with how many moles of hydrochloric acid. So number of moles of hydrochloric acid needed. And how do we find that? Is by the reacting ratio. Okay, from the balanced chemical equation, we can tell that 1 mole of sodium actually reacts with 1 mole of hydrochloric acid. Okay, I know it's written as 2 is 2 reacting with 2, but if we reduce it to the simplest ratio, it simply means that 1 mole of sodium will react with 1 mole of hydrochloric acid. So number of moles of hydrochloric acid needed is actually 0.1 moles. Okay, now how many moles of hydrochloric acid is present? It is 0.5 moles. Okay, so number of moles of hydrochloric acid present is more than the number of moles of hydrochloric acid needed. What does it mean? It simply means that your hydrochloric acid is in excess. This would mean that your sodium is limiting. Okay, so let's do the opposite scenario, where if I were to pick hydrochloric acid as the reactant for step 2. Okay, so I know that we have 0.5 moles of hydrochloric acid. Right, now we need to find out 0.5 moles of hydrochloric acid will react with how many moles of sodium, and we can find out by comparing the mole ratio. Again, it's 1:1, so number of moles of sodium needed will be 0.5 moles. Okay, and the number of moles of sodium present is 0.1 moles, which is less than the number of moles needed. Alright, so what does it mean? It means that sodium is limiting. We don't have enough. Okay, and then your hydrochloric acid is in excess. Alright, so regardless of whether you use sodium or hydrochloric acid for step 2, you will still arrive at the same answer, so no worries. Okay, so the limiting reactant or the limiting reagent is actually sodium. Now calculate the number of moles of reactants that remain. So there will be some of the excess reagent that's left over. Okay, how much left over we need to look at here. Okay, we need to look at here. So again, 0.1 moles of sodium will react with 0.1 moles of hydrochloric acid. Since we have 0.5 moles present, the number of moles of HCl remaining will be equals to number of moles present minus number of moles needed. That will give us 0.4 moles of hydrochloric acid for part B. Okay, let's revisit the pudding example. So this is the same one. We have 3 puddings and 10 raspberries. How many bowls of dessert can the chef make? The answer is 3. Even though we have a lot of raspberries, the number of moles of dessert is limited by the number of puddings that we have. Now even if I were to change the question to 3 puddings and 20 raspberries, the number of moles of dessert will still be 3. If I change the question to 3 puddings and 100 raspberries, the number of bowls of dessert will still remain at 3. So what am I trying to drive at here is that the amount of product in a reaction, okay, it only depends on the limiting reagent. Okay, it doesn't matter how much of the excess reagent that I have, it's not going to change anything. The amount of limiting reagent will affect the amount of product formed. As mentioned, this is the most important. The amount of product formed depends on the amount of your limiting reagent, not the excess one. Okay, so in order, when you want to find the number of moles of your product, you need to compare the mole ratio between the limiting reagent and your product. So back to the calculation question. So just a while ago we found out that the sodium was limiting and then hydrochloric acid was in excess. Okay, and we have solved part 1 and part A and part B. Now in part C we need to calculate the mass of sodium chloride formed. Alright, so we have already found number of moles of your reactants. Step number 2 is to compare mole ratio. What do we want to compare? We want to compare the mole ratio between the limiting reagent and what you want to find, which is your sodium chloride. Okay, so from the balanced chemical equation, again we can find that 2 and 2. So essentially the simplest ratio means 1 mole of sodium will react with 1 mole of sodium, will form 1 mole of sodium chloride. Okay, so number of moles of sodium chloride will be equals to number of moles of sodium, which is equals to 0.1 mole. Okay, and lastly we need to calculate the mass of sodium chloride. So convert from moles. To find the mass we need to multiply it by the molar mass. Okay, so that will give us, let me see, 5.85 grams. Now let's practice what we have learned on another question. So this question is actually quite complicated, but let's take it one step at a time. So this question, we are looking at the reaction between CCl4 with SbF3, antimony trifluoride, to form a gas which is called Freon 12. Okay, I know the reactants and the products sound very unfamiliar, but please do not be intimidated by that. The same approach will apply. Okay, so the question tells you that I have 150 grams of CCl4 and 100 grams of antimony trifluoride. Now before I even go on, again the amount of both reactants are given to you, so that is a clear signal for you to find the limiting and excess reagent, even if the question doesn't tell you so. Okay, so the question requires you to find the mass of your Freon 12 that is formed, but again, before that, we need to find which reagent is limiting and which reagent is in excess. So step number 1 is to find number of moles of both reactants. Number of moles of CCl4 is equals to the mass divided by the molar mass, which is 154, and that will give us a value of 0.974 moles. Okay, next we need to find the number of moles of SbF3, which is equals to 100 divided by 122 plus 19 times 3, so that is 179, and we will have a value of 0.559 mole. Okay, so step number 1 is to find number of moles of both reactants. Next, step number 2, we have to pick one of the reactant, any one of them. Okay, I'm going to pick my antimony trifluoride. Okay, so I know that the number of moles of antimony trifluoride is 0.559, and based on that, number of moles of CCl4 needed to react with this number of moles of antimony trifluoride is actually equals to 0.599 multiplied by 3/2. Okay, how do I get 3/2? Right, it's from the reacting ratio. Okay, 3 moles of CCl4 will react with 2 moles of antimony trifluoride. If the fraction is not obvious to you, now let me teach you a way. In order to get the correct fraction, what we can do is this: we can find number of moles of CCl4, number of moles of one reactant over number of moles of the other reactant is equals to the ratio of the number in front of it. So the number in front of CCl4 is 3, the number in front of SbF3 is 2. Okay, so if by looking at the equation and whether you multiply by 3/2 or multiply by 2/3 where it's not obvious to you, you can use this. Number of moles of one reactant over the other is equals to the ratio for the number in front of it. Okay, so number of moles of CCl4 needed is actually equals to 0.838 moles. Okay, and the number of moles of CCl4 present we have found earlier is actually equals to 0.974 moles. So what does it mean? The number of moles present is more than the number of moles of CCl4 needed, and that would mean that your CCl4 is in excess. Okay, and your SbF3 is your limiting reagent. Okay, so for part A, we need to find the mass of your product that can be formed. So once again, we need the second concept that was being learned, which is the amount of product depends on the limiting reagent. Okay, so now we need to look at the limiting reagent, which is my SbF3, and we want to find the amount of product that is formed. So what is the reacting ratio here? The reacting ratio is 2 moles of antimony trifluoride will give me 3 moles of freon 12. So the number of moles of freon 12 is actually equals to 3/2 times the number of moles of SbF3, which is 0.559, and that will give us the same number of 0.838 moles. Okay, next we need to find the mass. So how do we find the mass? Is to take the number of moles multiplied by the molar mass, which is 12 plus 35.5 times 2 plus 19 times 2, that will be equals to 121, and then we get a mass of 101 grams. Okay, now we move on to part B. Part B, you are supposed to find the mass of the unreacted excess reagent. The excess reagent that we are looking at is carbon tetrachloride. Okay, so we need to find the number of moles of CCl4 that was in excess, that was remaining. Okay, for that we take the number of moles present minus the number of moles required. So this will give us the number of moles that is remaining. Okay, after finding number of moles, once again we can find the mass by taking number of moles multiplied by the molar mass, which is 154, and that will give us a mass of 20.9 grams. Okay, so the two important concepts that we have learned in this lesson is this, that when the amount of two reactants are given in the question, we need to determine which one is limiting, which one is in excess. How do we do that? Is to convert is to find number of moles of both reactants. Pick one and use mole ratio to find out how much of the other one is needed, and then you compare to how much of the other reactant that is present to determine which one is limiting and which one is in excess. And then the amount of product that is formed will depend on your limiting reagent, right? So you look at the limiting reagent and the product that you want to find, and you look at the mole ratio to obtain the number of moles of product. Okay,